at the intensity versus the frequency. So intensity is how bright the light is, i.e. the number of photons on the metal surface per unit time. Each photon still has the same frequency, i.e. each photon still has the same energy. So how would increasing the intensity of incident light change the current read through the ammeter? Well, if our frequency is greater than our threshold frequency, this means the higher intensity means more photons per unit time, which means more electrons are ejected per unit time with the same kinetic energy as before. This means we have more electrons moving through the ammeter per unit time, and hence the current is going to increase. Now, what if we have our threshold frequency being greater than our frequency? Well, this means there's going to be no current since the photoelectric effect does not take place. So now let's take a look at frequency. Frequency is what color the light is or what type of electromagnetic radiation it is. So the energy that each photon has. The number of photons per unit time or brightness is unchanged by the changing frequency, which is really important to remember. So if we look at this example, which asks how would increasing the frequency change the reading on the ammeter? So in A, if the frequency is always greater than the threshold frequency, well, a higher frequency means more energy in each photon. Each electron is ejected with a higher kinetic energy. However, the same number of electrons are going to be ejected per unit time since there is the same number of photons. So this is going to mean that the current remains the same through the ammeter. But now, question B asks, what if the frequency is always less than the threshold frequency? Well, there's going to be no current since the photoelectric effect does not take place, just like in our last example. If we're looking at emission versus absorption, an electron can release energy by emitting a photon by moving down in energy level. This is what we refer to as emission. So you can see here, we have an electron and it's releasing energy by moving down in energy level. So it moves from E3 to E1. Now, absorption is the opposite thing. So the electron can now absorb energy from a photon by moving up in energy level. You can see here we have it moving from our energy level 1 to energy level 3. So let's take a look at this example. It says an excited electron is in the 4th energy level of an atom. Calculate the frequency of the light emitted if the electron drops from the 4th to the 1st energy level. So pause the video and give this one a try. Right, I hope that went well. Now let's look at the answers together. So we're saying that our electron drops from the 4th to the 1st energy level. So if we work out the difference, this is going to be E4 minus E1, which is just negative 1,36 times 10 to the negative 19 minus, and let's put this in brackets so we don't confuse our minus signs, minus 5.76 times 10 to the negative 19. And this will give us an answer of 4.4 times 10 to the negative 19, and because it's energy, it's measured in joules. Now, if you swap the E4 and the E1 around and now you got a negative answer, don't worry about it, just switch the sign of your answer and use the positive version. So now we're going to use our equation E is equals to HF. So we've just worked out E, and that was 4.4 times 10 to the negative 19. We know what Planck's constant is. You'll find that on your data sheet, and that is 6.63 times by 10 to the negative 34 times by F. So now if you work out F, you should have gotten 6.64 times 10 to the 14, and remember that frequency is always measured in hertz. So now let's just talk a little bit about the emission spectrum. So heating the gas causes electrons to move up to a higher energy level due to the energy that is gained. So when those electrons drop back down to the lower energy levels, they emit photons. And the photons emitted are of a particular frequency because the electrons are in specific energy levels. So we can't have electrons floating in just anywhere. They have to be in a specific energy level. So in the previous examples, there was E1, E2, E3, and they have to be in one of those. And if we just want to talk a little bit about the absorption spectrum, so white light contains all the frequencies of light, and it is passed through a cold gas. And when this happens, the electrons absorb certain frequencies of light and move from a lower to a higher energy level. The black lines on the picture above correspond to those frequencies of light that have been absorbed by the electrons. Thank you for joining me today. I hope this helped, and see you next time.